I'll get to the adhesion code examples, but it's pretty established that the industry, the marketplace, has moved away from C because of okay. Am I basically out of time now?
No.
How much time do I have?
15 minutes.
15?
According to the... Should be ending at 3. No, it should be ending now. But
Oh, it should be ending now.
Should be ending at 3, so there's a 15-minute gap.
no, 3 o'clock is the message. Let's check.
Okay.
Yes.
So I'll move along. Let me go back to Balmer Beaton.
2:45.
Okay. So I'll let Ollie take the stage.
No, I just wanted to warn you.
Okay. Does anyone have any more questions, especially about the telephony building block thing, about adhesion? I have some slides about adhesion that I guess I won't go into. Well, here, let me go into them just quickly. These are a couple things that I isolated as the issues with extensions.conf. I think they're pretty established. Conditional looping and branching variables, data structures, database integration, use of third-party libraries, which is basically code reuse, extending that language, error handling, there's no such thing as an exception, date and time handling, pattern matching. So the adhesion experience, this is like the most basic thing I can communicate about adhesion, is you have this AND command, AHN, which lets you create an application. You do AND create some name that generates a folder which contains the entire project. When you modify files within that standardized directory structure, you can then take that directory and send it to other people. They do AND start folder name, and the only modification to Asterisk they have to make is adding this line to extensions.conf, which basically calls AGI, given the IP of the system. And this is a code example. This is showing how to basically use queues and adhesion. It's basically calling out to Asterisk and abstracting things like the waiting count. Waiting count is encapsulated within this queue object. So it's basically calculating a ratio of the waiting count divided by the number of agents in there, and seeing if that's over than 4 agents for every person in the waiting queue. And if the ratio is too high, then let's send an email with a template that's already pre-written, passing in the size of the people waiting, and then join the queue anyway. This is generating the config file for queues out of a database. For group and group.findAll is a Ruby abstraction of going to the database. Show me that mark in C. And then iterating over it. For group and group.findAll is basically creating this object relational mapper that returns an array of object abstractions of records in the database. And so queue group.name basically does select name from groups where name equals whatever name it is.
This is just syntactic sugar around the same things you can do. It's just this is.
So what you call syntactic sugar is basically productivity. This whole thing is like what? Like 15 lines of code as opposed to what it would be in C. With all the database access and so forth. So.
Yeah, but you're hiding all the rest of the code that had to be created.
But that makes it more productive. By creating abstractions,
You do the same thing with the C library. You see what I'm saying? In other words, the reason this is so easy is because you've done so much work already on the back end to make it it's easy. Which I'm not trying to knock it. I think
so you can,
this stuff is fantastic, and that you
keep in mind.
Toolkit for building applications.
Keep in mind this is very object oriented, and the rest of Adhearsion is very object oriented. You can't do that in C. Ollie?
You've seen all the changes we've done to the internal Asterisk API. We're not writing on a detailed level anymore. We're writing on a very high abstracted level with ASD objects, lists, and other stuff. So we changed the Asterisk API during the years. So we're not writing in C details anymore. We're writing in not as high level as this, but in a higher level raw C.
Yeah, and I look at the Asterisk code like several times a week.
Take the header files and compile Asterisk like a library and actually expose it to any language that wants to use it. So.
Absolutely, and what you're basically saying is you're creating a C-level abstraction of Asterisk.
So Asterisks are not like an executable anyway. It's something that's
Yeah,
with your Ruby code.
Totally, it's a C-level abstraction of Asterisk, but you could have an abstraction of Asterisk that works over a socket, for example. And for that kind of low-level application potential, you would have to define those building blocks and expose them to whatever transport medium. That could be like the same C, it could be like C opcodes, you know, compiled into machine code, or that could be over a socket. And just to integrate with Java is an example of that. And this is a menu in Adhearsion. Basically, you give it the number of tries, the timeout in seconds, and link.employee tree, link.conferences. Employee tree and conferences are other contexts within Adhearsion. And so you're saying on 9, go to the employee tree, which has its own, you know, employee tree curly bracket, just like IVR up there, containing a specific dial plan implementation. Link.conferences goes to the conferences context whenever 800 to 899 is entered. Link.group dialer basically pulls out, in that one line of code, Mark, that pulls out every single group in the database and executes the IVR option method on it, which basically creates an array of all of the IVR options, all the like IVR like digits assigned to a group, like 1 for sales, 2 for tech support, 3 for finance. Those are stored in the database and then passed to this group dialer method, which will be executed whenever someone enters any of those digits. And so you're basically storing the entire IVR in the database and linking it to other sections in the dial plan. On premature timeout, whenever the timeout up there was encountered but it hasn't exceeded the number of tries, then execute this nested context. This is one of the benefits of Ruby, is that you can have blocks, which is, you know, passing code to more code, basically, a la lambdas from Lisp and Smalltalk. On invalid will be executed when none of the patterns are matched. And it does the pattern matching proactively. So as soon as you press a digit that's invalid, it knows immediately, because it can compile basically a state machine from all of those things you've listed there. And whenever all of the tries have failed, you can specify another nested dial plan, or context, I should say, which says something and then goes to another context that like handles everything. So quick run through Adhearsion. My time is up. And any last minute questions?
Have you integrated this into any distro or anything? Or?
Have I integrated Adhearsion into any distro?
One of the Asterisk distros.
No.
Asterisk now.
If you integrating it into a distro is like apt-get install Ruby gems, gem install Adhearsion, that's it. You have Adhearsion on your system.
And just another question, what are the big, have you personally done any kind of cool apps on this that, you know, you can maybe try out or something?
Yeah, I've done basically like a switchvox application written in Adhearsion that will be open source soon. But it's basically a high-level PBX with dynamic groups, dynamic employees, dynamic conferences. You can change all that stuff in the database. Yeah. So it's a pretty powerful little solution, and yeah, that will be open source soon. And working on a couple other projects that are under NDAs, but you know, they're interesting startups that have an interesting use for voice, and they chose Adhearsion for that. So, any other questions? Like last question.
You mentioned something about presence.
About presence earlier, yeah. So, so in your Adhearsion dial plan, say in employee tree, the context which encapsulates the logic for dialing an employee, you could, in your dial plan, like straight in your dial plan, imagine doing this in extensions.conf, you could enumerate, say, everyone with the status available, and then check if so-and-so is included in that array, as an example of presence. You could have